without our calculator. Okay. But before we start without our calculator, let's start with our calculator. So would you get out your calculator, and in a standard window, graph this guy. Now don't multiply it out. Just go ahead and put in the parentheses. And did you get something that looks like this? Okay, interestingly enough, look where it crosses the x-axis.
2 points.
1, 2, 3.
Look at the points. What's this?
-2.
1, 3.
Anything coincidental about that?
It's in order.
No, look at the factors. If you set that equal to 0 and solved it, what would x be? 1, -2, 3. The factors give you the x-intercepts, or the zeros. All right, now I want you to sketch this one. So leave the window the same, take that equation out, put that one in. This one has a little bit different behavior. What do you notice about this one? Does it cross the x-axis where you, or touch the x-axis where you would think? At -1 and 3? But it's a little bit different here, isn't it? As compared to what happened in this problem. What's different about that?
Only crosses twice.
Well, it only crosses twice, and when its behavior right here, it bounces off. Why do you think that might be? Because the factor is squared. And what kind of behavior do you expect with squared things? Now, this is not a true parabola, but it has the characteristics of a parabola, right? One more. And this one you probably know without doing it on your calculator. Go ahead and do it on your calculator. Sketch that. Did you kind of expect that?
Yeah.
Because you know what a cube looks like. And what does the +1 do? Backs it up 1. So you okay with that? All right, one quick comment, and then you're going to put the well, you can go ahead and put the calculators away, because the next one we do, we're going to do without a calculator. But you remember on Friday, I talked about end behavior of odd degree functions and even degree functions. What did we say if the degree of the polynomial is odd? And notice, if you FOILed this out, it would be x cubed. What did we say if the degree is odd, Lily?
You start at the bottom and end
Start at the bottom and end at the top, unless we put a negative coefficient on it that turns it upside down, right? So does it make sense that each of these starts at the bottom and ends at the top? Yes, because they're all cubes. All right? All right. Now, put your calculators away. Without your calculator now, just based on what you have observed up to this point, I want you to sketch this polynomial. Now, he is a monster. But you are going to sketch this without a calculator. Before you do anything else, you're probably going to plot a few points, right? Which points are you going to plot?
3, 5, negative
You're going to plot 3. X is 3. And what about this one out here? 0. That's a 0. And 3. And then 5. And then negative 1. And negative 4. You okay with that? What's the degree of this polynomial? If you were to FOIL all that out,
2. Wait.
4.
4.
well, that would be an x squared, and that would be an x squared. So that's 4. 5, 6, 7. You times out all the x's, you get x to the 7, which is odd, which means the curve's going to start where? Down here, right? So the curve starts down here and it comes up and it hits that point. Now you got 3 choices when you hit that point. You go right through it, you bounce off of it, or you squiggle through it. What determines which of those it is? How do you know whether you're going to go straight through it, bounce off of it, or squiggle through it? How do you know, Bailey?
If it's square, it's going to bounce off.
You look at the factor it came from. This is the factor that root came from. Notice, like Bailey said, it's squared. So we know the curve is going to bounce off. Now at some point, it has to turn around and connect with this point, right? We have no way of knowing how far down that goes. So just go down and turn around somewhere. Now what does it do when it hits that point? Well, that came from this factor, so it bounces off again. And then it's got to hit that point. It's got to connect that point. All the points have to be connected. This is a polynomial curve. It's continuous. So now we're at this one. What happens when it hits that one? It just passes right through, right? And then it's got to turn around and come down to here. What's it do when it hits that one? Just goes through. Connects with this one. What's it do when it hits that one? And are we ending the way we thought we should end? Yes, because it's an odd degree polynomial. It should start down and end up. So you just sketched that guy. And it's not perfect because we don't know how high and low these valleys and hills are. But that's a pretty good sketch. All right, let's try to try one more, and then we're going to step it up a notch. you're gonna put on your graph. 3, you're gonna put your x-intercepts, your zeros on. Zeros come from the factors. -1 and -5. Okay? Now, like all polynomials, this is one smooth, continuous motion. So it's either gonna start down here and flow through, or it's gonna start up here and flow through. How are you gonna make a determination which one it is? You're gonna check the degree of your polynomial. If you FOILed it out, how many x's would you have? X to what power? 4. It's an even degree polynomial. How do they behave? Start up, end up. Unless you put a negative coefficient on them, and then they start down and end down. So this guy's gonna start down here, he's gonna come up and grab that point.
Does the 2 do anything to
The 2 is gonna change the height of the curve. It's not gonna impact the zeros or the general shape at all. Like all multipliers, Hannah, the 2 controls size.
Wait, starting on ending down because it's a negative.
Yeah, it's an even degree. Should be starting up, ending up. Okay, what's it do when it hits this? Goes through it, comes up and grabs this point. What's it do when it hits that one? Goes through it. Comes down, grabs this one. What's it do when it hits there? Bounces off, turns around, and goes back down. Is that what we expected? Yes. Anna?
So the ones that go through and then come back, how do you differentiate them from parabola if they're just kind of going to curve anyway?
You mean like this right here?
So yeah, the ones that, like the first one that went through the 5, it's not technically like the parabola one.
No, because we're talking about the behavior at the 0. It's
Okay.
going through. We're not talking about the shape that comes after it.
Oh, okay.
We're talking about what does it do when it hits the
Okay.
x-axis.
Goes through the line.
This one goes through, this one goes through, this one bounces off.
Okay, interesting.
Okay, what are you thinking? You're thinking this is really easy. But what's been so wonderful about the way the problems have been presented?
And giving them.
They've been factored for you. And that's really the key, isn't it? They have been factored. What happens when they're not factored? Well, you have to factor them. And sometimes that's easy. For example, you're going to sketch this with no calculator. If it looked like this, you could do it in a matter of 10 seconds. But it doesn't. So step 1 is make it look like that. So what do you think? Can you see any factoring that might happen on this guy? Matt?
Take an X out.
Absolutely, we could take an X out. And that would leave us with x squared minus 2x minus 3, perfect. And then since we all passed algebra 1, x minus 3, x plus 1. Now it's factored. So now sketching it is a no-brainer. Where are you going to put your dots? You got 0, the plane x is a 0, the origin. So you got 0, 3, and -1. You know that the degree of the polynomial is cubed, it's positive, so you're expecting it to start down here, right? None of our factors is squared. So what does that mean? Every time I hit the x-axis, what am I going to do? Go right on through. So I'm just going to go right on through, connect my dots, and there you get it. if we are interested, and I think there was one homework problem tonight where they ask you to actually find the maximum and minimum, You've done that before, you will need a calculator to do that. Okay? Well, that was still pretty easy. Let's see about this one. This is a big, bad, scary problem. It's not the biggest or the baddest quite, but it's getting close. Because you need to factor this, and it doesn't group. Would you agree with me when I say that? It doesn't group. It isn't that I couldn't, put things together and take stuff out, but I'm never going to get a common parentheses here when I try to group these guys. Shoot. Any thoughts? You did this last year, I think. Jamie?
Synthetic division.
This is going to involve synthetic division? Well, it involves division. I choose to do it synthetically because that's easiest. Do you remember what you're dividing, Jamie, or what your purpose in division is? Well, it has to do with the last number, but not necessarily the opposite of it. Is what she's saying ringing any bells for the rest of you? The last number is part of the conversation, Lily?
Oh, I was just thinking.
Oh, good.
Your remainder has to be 0.
Your remainder has to be 0, exactly, because, think about this, if these are factors, then doesn't that mean if you did the division, you would get a remainder of 0? Think about it. If I say 5 is a factor of 20, what does that mean? 5 goes into 20 evenly, no remainder. 6 is not a factor of 20 because when you divide 6 in, you get a remainder. So what kind of the whole group here is saying is we need to find things that when we divide them in, we get no remainder. How many things are there out there in the world? A lot, right? So kind of where Jamie was sort of going is we can narrow down our options. If I am just going to start guessing things to divide, which is where I'm at right now, I'm just going to start guessing things to divide and try to get a remainder of 0. What should I be guessing? Bailey?
Something has to do with 12, like the most factors of 12.
It definitely has to do with the factors of 12.
Then the P's and Q's.
And it has to do what?
Like P's and Q's.
Exactly. We are looking for what are called the possible rational roots. And I will refer to those as our PRRs, possible rational roots. And you have kind of all come up with, it's the factors, the possibilities, the numbers we're going to guess. And this is a guessing. There's no other way other than the calculator. There's no other way. You just start guessing. Factors of the constant, which is 12. That's the plain number. Over factors of the leading coefficient, which for us is 1. So the numbers that we are going to guess, are factors of 12 over factors of 1. Now, I'm sure Blake is sitting here thinking, that that's a lot of numbers to guess. I don't really want to guess all those. And he's right, there are quite a few numbers there, but not compared to infinitely many, right? So we're glad we have a way of at least narrowing it down, even though we still have quite a few to check. Okay, so here we go. We're going to divide. Anybody want to guess something off the bat? -2. Now we're going to go through synthetic division for those of you that may have forgotten. Because I don't want to do long division, it just takes up too much space. So I'm going to do synthetic division. So she said we're going to check -2. So I put -2 in a little box out here. And then I write down all of my coefficients, including any negatives. So 1, -6, 5, and 12, I write them all down. You're probably using notebook paper, so leave a space there and draw a line across, because you're going to put some numbers in here. And you remember what you do now? The 1 comes straight down. Always, 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 whatever's in that position. And it may not be a 1 in every problem. It may be a 2 or a 5 or something. Bring it straight down. Then we multiply. -2 times 1, and we get -2. And then we add these. And then we multiply -2 times -8, and we add these. Uh-oh. Now you just did a division problem. The quotient that you came up with, remember this is what you started with. The quotient that you came up with is 1x squared minus 8x plus 21 minus 30 over x plus 2. This is your remainder. Is this a factor? Because that didn't turn out to be 0. Okay? I do want to show you one thing while we're here that you can take or leave. If I were to go back to the problem and think of it as a function, and just plug in the number -2. Not do all the division, but just plug in -2. I would have -8 minus 24 minus 10 plus 12. What does that add up to? -8, -24, -10 plus 12.
30.
That adds up to -30. It's not a coincidence. You can get the remainder 2 different ways. You can actually physically divide, which is fine, or you can just crank the number through the function and see what it turns out to equal. What would I want this to equal? 0. Okay, but it didn't. All right, so now I have to guess something else. Anybody have an idea?
-1.
-1? Here we go again. Uh-oh, this looks promising. There we go. We got the 0 that we had hoped for. Good news. What's left down here? What's this quotient, the leftover part here? What is that? X squared. It's a quadratic. X squared minus 7x plus 12. Now, if you want to continue guessing, feel free. I'm not going to. When I get it to this point, quadratic, I'm just going to go ahead and factor it. Does that factor?
Yeah.
X minus 3 minus 4. So what are the zeros, x-intercepts, of this problem? Remember, this is the one we're graphing. There should be 3 zeros. It's a 3rd degree. There should be 3 zeros. What are they? -1, 3, and 4. Are any of those squared factors? Are any of them repeated? Nope. They all happen just once, right? So what does that tell me about my curve? Just goes up and down and up again.
You have to make it a big, because I was the numbers. So that way you don't change the sign.
So start to finish, you just graphed this polynomial without your calculator. Who would have thought you could do that? Vincent?
Where did you get the -1?
It was a guess.
Okay.
It was a guess. From this pile of possibilities right here. The first number we guessed was -2. It did not work. The second number we guessed was -1, and it did work. The other numbers that would have worked would have been 3 and 4. Those are the only 3 numbers that are going to work.
If the factors of the leading coefficient are other than 1, does that affect the numbers that you
Of
put
course
in?
it does. If there had been a 2 out here, for example, then you would not only have all the numbers we originally had, but you'd also have 1/2 and 3/2 as options. Because you have to put all of these over both of those. So like you have 1/1, but you also would have 1/2. You'd have 2/1, but you'd also have 2/2. Lily?
Wait, where did you get the -1, 0?
The number that we guessed in the beginning, when we divided it out, we got a remainder of 0, which means it is a factor. That's a factor, because when I divided it out, I got 0.
So if like the top one would have worked, it would have, the point would have been
-2.
0.
-2 comma 0. Yep, if you put it as it is, this point is the point -2 comma -30. So if I wanted to plot that, that makes sense. It's clear down here somewhere, -2 comma -30. It's a piece of information I don't really need, but I have it. Anybody else? All right, let's try another one. Your job is to sketch with no calculator. Unless the problem factors by grouping, you really have no choice other than to start guessing. I know you don't like that, but that's what we have to do. This does not factor by grouping, so we're going to start guessing. Let's list our PRRs to give ourselves a little bit of a more narrow field of possibilities. Although with a 24, there's still a lot, right? What are the factors of 24? 24, 12, 8, 6, 4, 3, 2, 1. And that's over 1. Now I'm going to point something out. I want it on your radar, because this can be a time-consuming process. There's no question about it. You need every hint you can possibly get your hands on. Remember what I said about there being 2 ways of checking if something were a 0 or not? You could divide it. What did I say you could also do?
Plug it in.
You just plug it in and hope like heck you end up with 0, right? Now I want you to think about this for a second. Think about plugging a positive number into this polynomial. Plug a positive number in here. Is there any way you're going to put a positive number into this problem and come out with a 0?
No.
No. So if you think about that ahead of time, you've just eliminated half your possibilities. You're not going to waste time with a positive. Okay. Well, what about some negatives. Anybody have a thought? -2. I'll just put this one in and see what happens. Actually, that looks pretty promising, Hannah. She got one right off the bat. Wow, good job. -2 works. So now I need to divide it out. Some of you may have already done that. So I'll divide out my -2. Yay, good news. Okay, what's left? X squared plus 7x plus 12, which is going to factor how? Plus 3 plus 4. And that is combined, Lily, do not forget Lily, that W back there. That's combined with the one I already guessed, which would be x plus 2. So we have roots, have it all bunched up here at -2, -3, and -4. Starts down and is up. What do you think? You all right with that? Lily?
Oh, so the last one we had -1, so then we plugged it in on -1, but then for this one it was -2, and we plotted it. Oh no, you. So
I
it's
plotted?
+2, and then you plotted it.
The factor, yeah. Just like when the factor was x plus 3, I plotted it at -3. All right, one more, and then I'll shut up for the day. Audrey?
I have a question. So the leading coefficients 2, you divide whatever you guess by 2, and then you just look over.
No. Well, now wait a minute. If there's a 2 out here, then that was somebody else's question a minute ago. That simply means when I do my PRRs, factors of constant over factors of leading coefficient. Now there's 2 factors down here. So that means when I start considering numbers, I consider 3 over 1, 4 over 1, 24 over 1. But I also consider 24 over 2, 6 over 2, 3 over 2, 1 over 2. I consider everything over 2 also. So it doesn't change these guesses. It just adds in some new possibilities. Lily?
So say instead, or really, could you divide the 2 out of the whole equation?
You can't unless it is set equal to 0. If it's set equal to f of x, no, because dividing by 2 would mean 1/2 y over here. And that's still going to impact your y-intercept then, so no. Okay? Rose, you have a question or are you just stretching? All right, here's the last one. And I'm going to be still and let you hash it out with your partner, or maybe do it yourself, whatever. And of course, I put a little curveball in it. Your job is to sketch without a calculator. Now, what's the curveball? It's an x to the 4th. Now what that means is, you're going to guess just like always, you're going to divide. But when you do your synthetic division, the thing that's left is going to be an x cubed, right? After the first division, it's going to be an x cubed, which means you're going to start all over again, guess another number, divide it out, and then you'll be down to a quadratic. Okay? Go for it.
So when you do the synthetic division, do you have 1, 1, and then you do 24?
Yeah.
Remember, your PRRs are going to be factors of 80 this time. So you won't try 3, for example. Okay, what do you think? Are you making any progress? You haven't? What's your set? Remember, that was our goal.
I did it backwards. So I started with -2 and just exclude
Oh, it doesn't matter. The order you do it doesn't matter. No, your job is to find those roots. The order doesn't matter. Okay, when you are, you have it sketched, get your stuff and go to the nursery medicine.
So both of those roots?
We have 4, we should have 4 roots, right kids? Because it's a 4th degree. So I got, and I hope I did it right, I got -5, -2, 2, and 4. Yeah. Grace says, okay, she tried -2 first, and it worked, so she divided it out. She said, can I try -2 again? And the answer is yes, because what's possible? It could be x plus 2 squared. So if a factor works, feel free to try it again. Now, if you tried, 8, and it didn't work in round 1, then never try it again. It's never going to work once it doesn't work. But things can work more than once. All right, anything else? Anybody else have a question about that? All right, I want you to stop and think about what you just did. I gave you this problem, and you just graphed it without a calculator. You should be feeling smart right now. So when mom and dad say tonight at supper, what did you learn today at school? Whip out that napkin and show them this, and they'll know they're getting their money's worth. All right, you got an assignment. You probably can't get it because it's on Schoology, so I'll give it to you, and you have 4 minutes to start it. And I want you to do so. It's in section 2.3.